These problems are for section 11-1 and 11-2. Try the first one. Find the square roots of 81 and 169. Okay. The square root of 81, we're looking for a number that multiplies out to itself by 81. 9. Actually, there's one more. It's not obvious. Positive 9 is one of the solutions. So yes, negative 9. Yeah, 9 times 9 is 81. Negative 9 times negative 9 is 81. So 9 and negative 9. So do it again for 169. 13 and negative 13. Okay, this is the notation for square root. 225. Okay, this is a little different. This one is just 15. Okay, there's a difference just because of the way I wrote it. All the square roots, this is specific. They want the positive one. If you saw something like this, they want the negative square root, in which case the answer for this one is negative 8. Take the square root, apply the negative. Yeah, so these are specific. Here, if they're asking for all the square roots, you need to tell me everything. Here, they're telling you exactly which square root they want. Okay. Try these problems. You need to identify if it's real or not real. All the numbers you've ever had before are real. The not real ones, here, for example, we can find the square root of 16. That's 4. Yeah, 4 times 4 is 16. The square root of negative 25. That one's not possible. Yeah, there's nothing that multiplies out to give us negative 25. This one is not real. This one is real. Square root of 103. It's ugly, yeah, 10 point something, but we do have a number that will give you square root of 103. So this one is real. This one, there's nothing that multiplies out to negative 64, so this one is not real. Okay. Figure out which ones are rational and which ones irrational. Rational, the definition is you can write it as a fraction, or rephrase, a ratio of two integers, whole numbers, well, integers. The square root of 5 doesn't come out nice if you square root. This one is irrational. Yeah, you can't write it as a ratio of two integers. This, if I square root, is negative 6, which I can write as a fraction, so this one is rational. It doesn't square root nicely. This one is irrational. Same here. This one also, you can't write as a ratio of two integers. Yeah, so the easy way to figure this one out is if you look at each of the square roots, if it square roots usually to a nice whole number, whenever you're square rooting a whole number, it should square root to a nice whole number. Yeah. So, but really, if the answer, I guess if the answer terminates, then you know it's rational. Let's change it up. You need to evaluate the square root of 1 minus y, where y is equal to 6. Is the result a real number? Okay, so you just plug it in. In place of y, we put 6. This is the square root of negative 5. Is the result a real number? It's not real. There's nothing that multiplies out to negative 5. It has to be the same. Okay, we'll change it up again. Determine the values of x that make the expression a real number. So we want all the possible numbers that make it real. Like think of some. 3. If I replace x with 3, that's square root of 4. Oh, that came out nice. So we know 3 works. Determine values of x. Okay, what else? 1. This is square root of 2. Doesn't come out nice, but we can square root it. So 1 works. What about 0? 0 plus 1. Square root of 1, which is 1. Okay, so that works. Can we go lower? -1. This is square root of 0, which is 0. Can we go lower? How about -2? You can't square root a negative, in which case this is not real. So we cannot go lower than -1. All x has to be greater than or equal to -1. Let's try it again. Determine the values of x that make the expression a real number. Now, when we did that last problem, we were just guessing. There's got to be a way to do this without having to guess until we find it. We could guess again, I suppose. Let's try 2. In place of x, we put 2. 4 minus 5. Oh, that doesn't come out. We're square rooting a negative. Okay, let's try 3. Okay, we can square root 1. So is 3 the lowest we can go? 2 doesn't work. 2.5. 5 minus 5. So that's possible. So is 2.5 the lowest we can go? See, problem here is we're still guessing. Yeah, there's got to be a way to do this without guessing. If you look at the previous problem, we know if we can just hit 0, that's our boundary. Anything below that is not going to be real. So same here. That's 0. Anything lower than that value of x is not going to work. So as long as whatever's here under the radical is not negative, then we know it's going to be real. So really, if we start with 2x minus 5, as long as it's not negative, it has to be greater than or equal to 0. And then we solve for x. X has to be greater than or equal to 5 halves. Okay, so yeah, again, we're solving for x, so we need to write our answer in set notation. Yeah, but this is how we do it without having to guess. So long we set it equal to or greater than 0, we won't be square rooting a negative. A few more. Simplify. You don't need to solve for x or y or anything. Just square root. This would give us xy. We could do them separately. The square root of x squared is just x. Square root of y squared is y. Yep. And it should have been obvious because it's the same problem. Try these. It's just like the one at the top. It's just x minus 1. A little more challenging. See, problem with this is you cannot just square root each part. If you look at all the previous problems, these are all factors, things that are being multiplied together. We should factor this. Yeah, these are addition. They're being added together. If I factor, I'll have x and x. I need 14 plus 4 and plus 4. Does that give us the 8x in the middle? Yes. So this really is x plus 4 squared. So the square root is just x plus 4. Let's try a couple more. Simplify. You can do this in parts. I would do each part separate. Yeah, they're factors. 25 and y squared are being multiplied together, so we can separate them. Square root of 25 is 5. Square root of y squared, y. One last one. Simplify. Again, we can do it in parts. Square root to 1/4, square root to x squared. We know that is x. Can you square root to 1/4? It's 1/2. Yep, 1/2 times 1/2 is 1/4. This is what we're looking for. Okay, that's everything you need to know to be able to do the first two sections. Hope that helps. We'll see you in the next one.